Okay, we are going to start with lesson 3.3 today. What you guys are expected to do while I am not here is to put these postulates, theorems, definitions, and properties into your foldable, take good notes, try that homework, and then ask questions on Monday if you have them. Okay, so section 3.3 is about proving lines are parallel. This first postulate is in your textbook if you cannot read this very well. This is the corresponding angles converse theorem. It says if two lines are cut by a transversal, two parallel lines, if they are cut by a transversal, the corresponding angles are congruent. Then the lines are parallel. Okay, so right here we have line J and line K. They are cut by this transversal. Because they are cut by this transversal, or the line that goes through, so this line right here is the transversal. Okay, if they are cut by that transversal, that means that angle 2 and angle 6 are called corresponding angles. Okay, and those are definitely congruent. So something else we get out of this is that the two corresponding angles are congruent. But this property needs to go, this postulate needs to go in your postulate section on your foldable. So take a second, write this down. This is out of your textbook. You can ask your wonderful substitute teacher to hit pause at this moment so you can write this down. This goes in the postulate section. Okay, for this example, we want to use that corresponding angles converse theorem, postulate, and we want to use that to help us solve for x. So we want to find the value of x that makes m parallel to n. Now we know from that theorem, because these are parallel and we want them to be parallel, if we want them to be parallel, those corresponding angles have to be congruent. So we can make an equation from these two angles. We can say 3x plus 5 is equal to 65. Okay? Now we have an equation. They are equal to each other because of that postulate that says if those lines are parallel, the corresponding angles are congruent. Basically a rule of thumb, when you have two parallel lines cut by a transversal, if it looks like it's congruent, it is. Okay, so these look like they're the same, that means they are the same. So we set up this equation, we're going to use our algebra solving. Okay, I end up with 3x equal to 60. I divide both sides by 3. I end up with x has to be equal to 20. Now my problem just tells me they want the value of x. They don't want a degree, so I'm done. Okay guys, now another theorem that we're going to talk about is the theorem that involves alternate interior angles. So again, we have those two lines cut by a transversal. Okay, when that happens, instead of we dealt with corresponding angles, which were kind of one on top of the other last time, now we're talking about alternate interior angles. Okay, and what that is, it's going to be inside those parallel lines, and we're dealing with angles 4 and 5. Those are inside the parallel lines, and they're opposite each other. Okay, those are alternate interior angles. And this theorem says that if you have alternate interior angles that are congruent, which they are because they're cut by a transversal, then that means our lines are parallel. Okay, so in this example, angle 5 and angle 4 are considered alternate interior angles. So that means that angle 5 is congruent to angle 4. So angle 5 and 4 are alternate interior angles. So that means that they're congruent, which in turn makes our lines parallel. Okay, please make sure that this theorem goes into your theorem section. If you want to, you can put a definition for alternate interior angles in your definition section. You don't have to, because to my understanding, I don't think it comes up in any of the proofs, but good to know. So alternate interior angles, opposite side of that transversal. Again, if it looks like they're congruent, they are for this example. Okay, here's another theorem. Now, the other one talked about alternate interior angles. Now we're going to talk about alternate exterior angles. Those are on the outside of the parallel line, on opposite sides there. Okay, so if two lines are cut by that transversal, the alternate exterior angles are congruent. That means that the lines are parallel. Please make sure that this theorem goes in your theorem section. I would definitely include a diagram with every single one of these theorems because they are so visual based. Okay, so alternate interior was on the inside between those parallel lines on each side of the transversal. Alternate exterior is outside of those parallel lines, again, opposite. So another set of alternate exterior angles could be right here and here. Okay, and by this theorem, when this happens, when they're cut by a transversal, they are congruent, which makes our line parallel. Okay, here's another theorem. Don't worry, we'll get to some more examples in just a second. This is the consecutive interior angle converse theorem. Okay, it should go in your theorem section. It says if two lines are cut by a transversal so that the consecutive interior, now here's a case where they are not congruent, but they are supplementary, meaning they add up to 180 degrees. Okay, then the lines are parallel. So what all of these theorems are doing is they're setting up a whole bunch of ways where your lines are parallel. Talked about consecutive angles, okay, which have to equal 180 degrees. We talked about corresponding angles, which are the same, and we talked about alternate interior and exterior. So please make sure all of these theorems get into your theorem section, okay, and we'll kind of summarize them in just a second.